this video, I am going to explain capacitors and capacitance. Capacitors are devices used for storing charges. In various electrical and electronic equipments, capacitors are used. Capacitors usually consist of two conductors. Then capacitors are connected to a potential difference. One of the plate will be positively charged, the other plate will be negatively charged. So here a capacitor is connected to a potential difference of V volt. Then as the potential difference increases, charge on this capacitor also increases. So Q is proportional to potential difference. This proportional sign can be replaced by an equal sign after writing a constant. This constant is what is known as capacitance. So this can be rearranged and you can write like this: C is equal to Q by V. So capacitance is defined as the ratio of charge given to the conductor to the potential difference. Charge is measured in coulomb, potential difference is measured in volt. So capacitance is measured in coulomb per volt. Coulomb per volt, another name is that is Farad, in honor of the scientist Michael Faraday. Farad is a large unit, then smaller units are there. 10 raised to minus 6 Farad is microfarad, 10 raised to minus 12 Farad is picofarad. Nowadays, capacitors are available in various shapes. Now let us see capacitance of a parallel plate capacitor. In a parallel plate capacitor, there will be two plates. Then when it is connected to a potential difference, one of the plate will be positively charged, the other plate will be negatively charged. So there is an electric field. Electric field between two plates, charged plate, is given by this expression: E is equal to sigma by epsilon 0. Our aim is to find out the capacitance. Capacitance E is equal to Q by V. Now we know electric field E is equal to sigma by epsilon 0. Sigma is the surface charge density. So charge per unit area. So sigma can be written as Q by A. Then in this expression, for the sigma we can write Q by A. So intensity of the electric field between the plates is uniform. You can see the gap between the line is same. So electric field is uniform between the plates. Then one of the plate is positively charged, so plus Q, the other plate is minus Q. Distance between the plate is D. Now since the electric field is uniform, we can write V is equal to E into D, where E is the uniform electric field. Electric field is a force acting on unit positive charge. Force multiplied by distance will give you the work done. Potential difference is the amount of work done for taking a unit positive charge from one end to the other end. So since the electric field is uniform, we can write V is equal to E into D, where D is the distance between the plates. Intensity, we can substitute this. E is equal to Q by A epsilon 0, Q by A epsilon 0, then this D. So you are getting an expression for potential difference. V is equal to QD by epsilon 0 A. Now capacitance is defined as the ratio of the charge to the potential difference. So for V we can substitute this, then this Q will get cancelled and epsilon 0 A will go to the numerator. So C is equal to epsilon 0 A by D. So this is the expression for capacitance of a parallel plate capacitor. Now during the derivation we used this expression. So this is the electric field when the plates are infinite. For the finite plates, field may not be strictly uniform. So there will be some bending of the electric field at the edges. So field may not be uniform. But if the distance between the plate is very small, then field can be considered to be uniform. Capacitance of a parallel plate capacitor is equal to epsilon 0A by D. Capacitance is directly proportional to the area. Area of the plates are large, capacity will be large. So more charges can be stored. Capacitance is inversely proportional to distance between the plates. Distance between the plates becoming lesser, potential difference between the plates also will become lesser. That means potential difference across the terminals of the battery will be large. So more charges will flow from the battery to the capacitor. So capacitance increases. A parallel plate capacitor consists of two plates of sides 5 centimeter of square plates of sides 5 centimeter. We have to find the capacitance of this parallel plate capacitor. Capacitance of a parallel plate capacitor is epsilon 0A by D. We can substitute the value for epsilon 0, 8.85 into 10 raised to minus 12. Area of the square plates, so 5 into 10 raised to minus 2 into 5 into 10 raised to minus 2, because it is given in centimeter, so you have to multiply. Area of a square is side into side, that is to be divided by D. Distance between the plate is given in millimeter, 1 millimeter, so millimeter is to be converted into meter by multiplying by 10 raised to minus 3. Then when you simplify this, you will get the answer as 22.12 into 10 raised to minus 12 farad. Suppose these plates are connected to a potential difference of 10 volt. Then what is the charge stored on the capacitor? The charge is given by this relation, Q is equal to C into V. Capacitance, this value 22.12 into 10 raised to minus 12, that is to be multiplied by 10. So when you multiply, you will get 221.2 into 10 raised to minus 12 coulomb. I hope you have understood the concepts. Thank you for watching.